Hello, welcome to section 4.4 where we're talking about systems of equations with, you heard me, 3 variables. Oh my goodness, 3 variables. What are we going to do with ourselves? I'm too excited about this stuff. Okay, so first of all, let's talk a little bit about, remember how when we were doing system of equations with 2 variables, you have one solution, no solution, and infinitely many. And where the ones that have solutions are considered consistent, and the no solution is considered inconsistent. And we call, the intersecting lines, we also call those independent, and the infinitely many solutions is called dependent. So there's an analogous version for 3 variable equations. Now, I don't know if you've heard this before, but when you have 2 equations, 2 equations where the variables are of degree 1, meaning there's no exponents, right? It doesn't, all right, there's no visible exponents. Obviously, the exponent is 1, the de facto, exponent is 1. But they describe lines, okay? So let's say, 8x plus 7 equals y or something. That's a line. Now, if you have a 3 variable equation, you're talking about a plane. Okay, just sink that in, let that sink in. It's 3-dimensional and they're all linear, so there's no exponents visible, right? All the exponents of the variable is 1. It describes a plane. And the general form is ax plus by plus cz is equal to some constant d. And every solution to the equation is what we call an ordered triple. So that's very cool. So we're going to get through the different possibilities, whether we can have one solution, no solution, and infinitely many if possible or not. So either way, so here, because it's 3 variables, there's more possibilities than there was when it was just 2 variables. So one solution is basically where you have a consistent system and independent equations. So notice it's like when the 3 planes intersect and they all intersect at one point. So see, this is the point here, P. So that's one solution. Now, no solution is considered an inconsistent system and the planes are parallel. They have no points in common. Another type of no solution is when you have 2 planes that are coincident. What does that mean? That means they're just like the same plane on top of each other. Here's one, here's one. It's exactly the same. And then it's parallel to the 3rd plane, so they have no real points that the 3 of them have in common. It's a solution if the 3 planes share that point or line or what have you, and in this case they didn't. Here you have 2 planes that are parallel and they each intersect the 3rd plane. Now 2 of the planes have points in common, but all 3 do not meet in the same place, okay? So that's no solution. This is another case of no solution. Another case of no solution is where each plane intersects the other 2, but they don't share any points, so no solution. And that's this really cool little image here. Infinitely many solutions are when all the 3 planes intersect in a line. So it's basically like, it looks like a pinwheel kind of thing, and they all intersect in this line right here. They all cross. So they share an infinite set of points, okay? Another possibility of infinitely many solutions, if you have 2 coincident planes or where they're right on top of each other, they're basically the same plane. And then those planes connect with the 3rd plane in a line. So there's infinitely many solutions. Then, of course, it's also the possibility that all 3 planes are coincident. So they're all, infinitely many solutions as well. Okay. How do we check if we have a solution of a system of linear equations with 3 variables? So we can check that by just how we do for 2 variable equations, right? We can just plug them in and see if it holds true for all 3 equations. So let's look here. So this would be x, y, z. So we're going to take this and see if it satisfies this system here. So we would do -2. So putting in the first one, so this is equation 1, 2, 3. In the first equation, -2 minus, and then y is -1, plus z, which is 3. And we're asking the question, what does that equal? Is that equal to 2 or not? So we have negative 2 plus 1 plus 3. So this actually is going to be 2 because this is negative 1 plus 3. So that's 2, which equals 2. So yes, it's just for the first one. So we need to check the second one. The second one, so this was equation 1, equation 2. We have 2 times negative 2 minus negative 1 minus 3. And does that equal negative 6 is the question. So here we have negative 4 plus 1 minus 3. That actually does equal negative 6, so that works. All right, so then we need to plug it into the third equation. We have 2 times negative 2 plus 2 times negative 1 plus 3, and we're trying to see, does that equal negative 3? Question. So here we have negative 4 minus 2 plus 3. Is that equal to negative 3? So this is negative 6. Negative 6 plus 3 is negative 3, and that does equal negative 3, so yes. So A is a solution. A solution, okay? It has to fit all 3 equations, and it does. So for B, let's go ahead and check that. So X, Y, Z. So for the first one, negative 4 minus a negative 3 plus 4, and does that equal to 2? So we have, well, this negative 4, using commutative property, these two can cancel out, right? So then we're just left with 3. Does that equal 2? No, not today. So that's enough. We don't have to do any more work here because we've already proven it false for one of the equations, and it has to prove true for all 3. So this is, no, it's not a solution. Not a solution. Okay. So what if we want to solve a system of equations with linear variables? It seems kind of daunting, but it's not. Okay. So basically what we do is we have 3 equations. We put them in standard form. If there are any fractions, we clear them. We take 2 of them and we eliminate the same variable from 2 of the equations. So then we're left with a system in 2 variables. We're left with 1 equation. Then we take 2 different ones and eliminate another variable, the same variable as we did before, and then we'll have a new system of equations and we'll solve that system. So I'll show you what I mean. It's best seen, just look at it. Okay, so here we have x plus 2y x minus 2y plus z is equal to 3. 2x minus y plus z is equal to 4. So what I'm going to do is I'm going to label this equation 1, equation 2, equation 3. So I'm going to take equation 1 and I'm going to multiply it. I'm going to get rid of the x, I suppose. I'm going to get rid of the x. I'm going to use 1 and 2. So I'm going to multiply the first one by negative 2. So negative 2 times 1. So then that's going to become, so negative 2 times the equation 1. That's going to look like negative 2x plus 4y minus 2z is equal to negative 6. And then we're going to add that to the second equation. We have 2x plus y plus z is equal to 4. So then these will cancel when we add them together. We get 5y minus z is equal to negative 2. And then we leave that here. So now we're going to take two other ones. I'll pick 1 and 3. And I'm going to eliminate the x again. So what I'm going to do is I'm going to take the first one. I'm going to multiply it by 3, negative 3 this time. And I'm going to get negative 3x plus 6y minus 3z equal to negative 9. And then I'm going to write down 3. So that's 3x plus 4y plus 3z is equal to negative 1. And then I'm going to add this together. These cancel. So then I get 10y. And interestingly enough, these also cancel. Okay, so then that leaves me with negative 10. So divide both sides by 10. And I get already y is equal to negative 1. So that was a lucky one. So now I can just plug that into here and solve for z. So 5 times negative 1 minus z is equal to negative 2. So then I get negative 5 minus z is equal to negative 2. So plus 5 plus 5. Negative z is equal to 3. So divide by negative 1. And we get that z is equal to negative 3. So that's that. Now we need to find x. So let's take this y, this z, and plug it into the first one to find x. So we get x minus 2 times negative 1 plus a negative 3 equals to 3. So then we get x plus 2 minus 3 equals 3. This becomes x minus 1 equals 3, and so x is equal to 4. Oh, what happened? Sorry about that. X is equal to 4. Sometimes it just does that. It's so weird. So my solution here finally is, x is 4, y is negative 1, and then z is negative 3. And that's your answer. Okay? And this will fit all three of them. Yeah. All right, so let's do another one. So because there's different types. So let's see this one here, for instance. It doesn't have, the first one doesn't have y, and the second one doesn't have an x, and the third one doesn't have a z. So what I'm going to do is I'm going to combine 1 and 2 and get rid of the z. Okay, that will leave me with something that's in terms of x and y. So what I'm going to do is I'm going to take the first equation, 3x minus 4z is equal to 0. And then the second equation, I'm going to multiply this by a positive 2. So equation 2 times 2. So that's going to become 6y plus 4z is equal to negative 6. So when I combine these two together, this is going to cancel. I'm going to get 3x plus 6y is equal to negative 6. So now this one and this one together will help me, I can solve the equation. So what I'm going to do is I'm going to call this one star, and then I'm going to call this one star star. Who knows why? Just because. So I'm going to take the star equation. I'm going to multiply this by negative 3. 2x plus 3y is equal to negative 5 here. So multiply by negative 3, I get negative 6x minus 9y equals a positive 15. And then star star, I'm going to multiply that by 2. Okay, so times 2, so star star times 2. So I'm going to take this and multiply it by 2, and I'm going to write it underneath here. That's going to be 6x plus 12y, remember I'm multiplying by 2, is equal to negative 12. Now these two I'm going to combine. This will cancel out. I get 3y is equal to 3, so y is equal to 1. So now I can plug this into here, the star equation, and then I can solve for x. So 2x plus 3 times 1 is equal to negative 5. I get 2x plus 3 is equal to negative 5. Minus 3 minus 3. So 2x is equal to negative 8. Divide by 2, x is equal to negative 4. So now I take either one and I can solve for z here. So I'll put it into this one here, the first one, and I'll plug in x to solve for z. So 3 times negative 4 minus 4z is equal to 0. Negative 12 minus 4z equals to 0, plus 12 plus 12. So I get negative 4z is equal to 12. Divide by negative 4, divide by negative 4. So z is equal to negative 3, and that's my answer. Negative 4, 1, negative 3. Okay. All right. So then you can kind of see what's happening. We're doing more of the same. Let's go ahead and do one more here. This one I'll solve, I'll cancel out x, I guess, because it seems pretty easy here. So I'll take the first one and then multiply the bottom one by a negative. Okay, so I have x plus 2y minus 3z equals negative 1. Multiplying the second equation by a negative 1, I get negative x plus 3y minus z equals negative 1. Okay, combining them, 5y minus 4z is equal to negative 2. Okay, so now I'm going to take these two and cancel out the x so I can get something in y and z. So I'm going to multiply this equation here, the second one, by a negative 2 so that I can cancel out the x's. So I'm doing that here. I'm going to get negative 2x plus 6y minus 2z is equal to negative 2. So I multiplied everything by negative 2. Then I'm going to rewrite the third one. 2x minus y minus 2z is equal to 2. So then combining, this cancels out. I get 5y minus 4z is equal to 0. So you see I have two things here. Oh, this is interesting. This looks like exactly the same, except that it's going to have a different value. So it looks like we're going to have a no solution here. And let's talk about why. But before that, let's go ahead and show why that's going to be no solution. Okay, so this will be star and this will be star, star. Fine. Okay, so I'm going to take star. So 5y minus 4z is equal to negative 2. And then I'm going to multiply star, star by a negative and then combine it. So if I multiply by negative, I get negative 5y plus 4z is equal to 0, because negative times 0 is still 0. These will cancel out, and I get 0 equal to negative 2, which is false. Okay, so this is a no solution problem. Okay. All right, so that's it really. I just, good luck. Practice elimination. Here is your homework. Happy studying, and I will see you on the next video.